Hey everyone, what's up? Welcome back to Subnet Zero. Today we will learn all about switch and how does it fit in all this, okay? So without further ado, let's jump right in. So for your understanding, this diagram that we always use, right? I have removed a lot of parts and I've neatened the diagram to ensure that we are able to understand this concept of switch properly, okay? So first let's understand why do we need a switch and what is its utility, okay? Yeah, so in the previous video, if you remember about ARP, to ensure all the computers are connected properly, we would need many cables. What do I mean by that? Let me demonstrate, okay? Let's say if we have 5 computers, okay? Let me make sure. 1, 2, 3, 4, 5. Okay? So now, when it comes to just using ARP alone and depending on cables to ensure all the computers are connected, we will need the wiring cable should be something like this. Let me use this peach color. It represents copper or fiber, okay? Copper or fiber optics. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see total like 10 cables we will need to ensure all the computers are connected with each other. But imagine if there are like 20 computers, 30 computers, 40, 50, 100, 200. Then essentially it'll be like an entire hodgepodge, an entire, mess full of like wires, and you won't be able to keep track of which wire belongs to what, okay? So essentially to physically neaten this whole mess up, okay, we have introduced the concept of switch. So how would that look like once switch is introduced? So imagine these very 5 computers and we have a switch in between, okay? So it will be like this. 1, 2, 3, 4, 5, okay? Only 5 wires will be needed and the switch will ensure that all the communication amongst all these 5 computers goes smoothly. Make sense? So this is the utility of a switch mainly, okay, to reduce the whole mess of wires that we might potentially run into, okay? So what does it look like? First, let me show you. This is a switch, okay? And these sockets that you see, which is labeled 1, 2, 3, 4, 5, 6, 7, 8, these sockets, they are called ports. Ports, ports, okay? And normally, how to make it functional is that we connect an Ethernet cable, the end point of an Ethernet cable in socket 1 and in computer 1, whichever computer you want to associate computer 1. Let me show you what it looks like. Here. You see this? Yeah. So Ethernet, this Ethernet cable is being connected into a socket. Okay, so that's how it works. So now when it comes to this diagram, let me zoom in. I hope my mobile viewers are able to see this properly. Yeah. Yeah. So when it comes to this diagram, let's see real time how this works. Okay. So before we understand how the whole switch works real time, I just want to inform you that this is PC1. It has the IP address of 192.168.0.1 and MAC address is AAAA or essentially all A's, okay? And this is connected to port 1. Let me just ensure I'm highlighting it properly so that there's no potential confusion. Let me use the color blue. Yeah. So this is connected with port 1. I'll explain later what do I mean by that, okay? Then there's PC2, okay? It's 192.168.0.2. MAC address is all B's and it's connected with port 2. Just keep this in your mind as of now. I'll explain the whole, how the jigsaw puzzle gets pieced together. Then PC3 is 192.168.0.3. MAC address is all C's. Port number is 3. By port number, I mean port number of the switch, okay? And then there is PC4. The IP address is 192.168.0.4. MAC address is all D's. Port number 4 of the switch. This is for your ease of understanding. If there's a singular format, the pattern recognition will be a lot easier. There won't be any room for confusion, okay? Make sense? So now let me add a switch to this. Let me add a switch in the middle of this network, okay? And how will this work, the switch? Okay, let's see it in action, real time. So while explaining you how the data flows through the switch, I will also introduce concepts one by one, okay? So then you'll be able to understand how it's related to this, okay? So first, let me use this peach color to ensure that all these computers are connected to the switch via copper or fiber optic cable, okay? So now let's get into PC1, okay? PC1 is this computer, okay? And remember, we are always going to use PC1 as like the standard, just for understanding, okay? As the standard in this diagram, which does the job of sending a data. Okay, make sense? Yeah. So now let's look at the Ethernet frame, okay? If you remember, again, just to recap, Ethernet frame is this, like a Russian doll, which is like box in a box in a box, okay? So the smallest box is the peach box, which converts hello to binary, and which is further boxes sealed in this blue box, which is what we call the payload, and this blue box is further locked and sealed in this brown box, what we call as the Ethernet frame, okay? So in this example, let's say if you want to send this to the IP address, remember the IP address sender and receiver addressing is done on the payload, okay? So let's say if you want to send it to 192.168.0.3, okay? Let's say that is PC3. And the MAC address of this would be CC, 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 all C's essentially, okay? So how would this work, okay? So this Ethernet frame has been completely boxed in with including frame check sequence and the whole 9 yards. Again, a recap if you have forgotten this, okay? Now let me take out a blue pen, okay? Blue marker. So, PC1, that is IP address 192.168.0.1, MAC address all A's. What it does, first it boxes this whole thing into an Ethernet frame. Then it will pass on the data to the switch, okay? And now what happens in the switch? You see this port 1, yeah? So first, the Ethernet frame goes in the Ethernet frame goes into port 1. And once it goes into this port 1 of the switch, it gets stored, this information of the Ethernet frame over here, you see? It gets stored in the MAC address table. Now, what is a MAC address table? Let me explain that. So, this MAC address table. So first, it will see who is this from. Okay, it's 192.168.0.1 from MAC address all A's. Okay, and this is PC1. So this will remember. The switch will remember this information. Okay, first is that it is port 1. Okay, port 1 is associated with PC1, and PC1 is associated with 192.168.0.1, and the MAC address associated with AA.AA.AA, all A's essentially. Let me just format this properly. Hold on. Fair enough? Yeah. So now that information has been stored in this MAC address table. Okay. Imagine, remember ARP cache that we did in our previous video? Similar to that. Okay. So yeah, so once it has stored all the details of the incoming Ethernet frame, okay, now it will look at this and it will be like, okay, now we have to send it to 192.168.0.3, that's PC3, and all C's, okay, the MAC address. But it is just a new switch. Just recently we have installed the switch over here. It doesn't really know which one of this is PC3. So what it does is, let me use the color green, it does the job of shouting. Remember that we did shouting, hey, which one of you is PC3, 192.168.0.3 with MAC addresses all threes? Please speak up. So it will give a shout. Imagine like a loudspeaker. You are in one room. It's like, hey, which one of you is named John? Please speak up in a large crowd, okay? Similar to that, it does this, okay? First, it will flood to PC3, PC2, PC4, all of them at once. This process is what we call as flooding, okay? Okay, this is what we call as flooding, okay? Yeah, makes sense? Yeah, so that's exactly what it is. So first, PC4 will be like, nope, not me. PC2 will be like, nope, not me. PC3 will be like, yup, that's me. So it will update the same to the switch. There will be a connection formed between PC1 and PC3. They can both communicate with each other, and while it is communicating with each other, because remember, PC3 will also send its Ethernet frame as well, okay? So the switch, what it will do is it will extract the data of the Ethernet frame from PC3 and it will update over here as well, okay? So now to remember port 3 is equal to PC3 is equal to 192.168.0.3, and MAC address is all C's. Okay? So essentially, next time whenever 192.168.0.1 wants to ever send it to PC3, the switch will be like, oh yeah, I remember, I have all the details. PC3 is 192.168.0.3 and MAC address is all C's. I don't have to break my brains over that. Okay? So this entire process of, where switch already knows, is already aware of all the details of the destination PC, and it forwards to it. That's the process of what we call as forwarding. It's simply forwarding the Ethernet. It's essentially just the forwarding the Ethernet frame to the correct desktop or PC when you already have the details. When you do not have the details, it ends up flooding the entire network till is able to extract the correct destination. Make sense? Yeah. So this is what a MAC address table is. And remember, the more interaction happens between all these computers, the more interaction happens with all these computers, the more the more information will be stored in its MAC address table. Okay, so this significantly reduces the stress of constantly flooding and constantly trying to like a treasure island hunt, like which one of you is the correct PC. Doesn't have to go through the headache all over again. Yeah, make sense? Yeah. So now let's come to the last part where we are at, is like what happens if, let's say, if PC2 has been unplugged from the switch. Okay, so for example, let me use this here. From PC2, okay, it has been unplugged. What happens when it comes to that? Okay, so the switch will understand, since this port number 2, okay, port number 2 is on the link layer, it has been disconnected. So it will know that this is essentially now not in use. Okay, it's pretty simple. It will automatically know that it's not in use, so not to bother with it. Okay, again, let me repeat. Whatever you see this transmission of Ethernet frame, right, it happens within the switch. So for example, let me just clear this out. Yeah, if PC1 wants to send a message to PC4, so majority of the interaction happens in the port. Okay, so the Ethernet frame goes from PC1 into port 1. Yeah, it will come out from port number 3 to PC3. Okay, once it's extracted all the, after flooding, it has extracted all the information. Now it knows its destination. That's how it does. This is what we call as forwarding. But if it does not know, it will shout to all the other computers. From port 2, it will shout to PC2, hey, are you 192.168.0.3? From port number 3, it will also ask, are you 192.168.0.3? From port 4, it will also ask, are you 192.168.0.3? So all the interaction happens within the ports. Okay? Make sense? So this becomes like a nice communication broker amongst all these computers, all these desktops. Make sense? Simple? Easy peasy? Yeah, so pretty much this is we have covered what a switch does. Okay, I hope this is useful in understanding. This clears all potential doubts, and this diagram also helps in understanding how the whole process of communication works, especially when the switch does not know which computer does not know the details of the computer it wants to forward it to. It resorts to flooding. When it knows which computer it has to forward it to, then it does forwarding. Make sense? Yeah, and also MAC address table. MAC address table essentially, in this whole forwarding and flooding process, it extracts all the information about which computer, which IP address and MAC address associated with which port. Yeah, makes sense? So the more details and the data it has, the more, the more it will be able to retain the information. Yeah, so if once the more information it has of all the computers, the better it will be able to just resort to forwarding. It doesn't have to do the whole process of flooding or shouting all over again. Okay. Yeah, so I hope this video was fun so far. Please consider liking, subscribing, and sharing this with anyone who might find this useful. Please hit the bell. Because you only scratched the surface so far, and there are plenty of topics which are coming up, and I promise you it will be fun each time we progress, okay? So thank you for watching this video and I'll see you in the next one. Bye.